aboard! This journey will explore plate tectonics, which explain how Earth's moving plates shape our planet. From forming mountains to causing earthquakes, this theory helps us understand Earth's constantly changing surface. Let's dive in! The plate tectonics theory explains how Earth's outer shell is divided into several moving plates. It evolved from Alfred Wegener's continental drift hypothesis in 1912, which proposed that continents were once joined as supercontinent and later drifted apart. Wegener's ideas were initially dismissed due to a lack of a convincing mechanism. In the 1950s to 60s, new discoveries such as the Mid-Atlantic Ridge, sea floor spreading by Harry Hess, and the paleomagnetic evidence led to the development of plate tectonics. This theory explains that Earth's lithosphere is broken into tectonic plates that move due to mantle convection, forming divergent, convergent, and transform boundaries. Key evidence includes earthquake patterns, volcanic activity, and direct measurements of plate movement via GPS. Today, plate tectonics is central to understanding geological processes like mountain formation, earthquakes, and ocean basin creation. Mechanisms of plate motion. Mantle convection. Convection current it is where heat from the Earth's interior causes the mantle to flow slowly in convection currents. These currents drag the overlying tectonic plates along with them. As the plates move, boundaries are created, which are convergent, divergent, and transform boundaries. 1. Convergent boundaries. Two plates collide to form mountains or a subduction zone. This can either cause one plate to go under and the other to be pushed up, or two plates to smash together and pushed upwards. This process can form a fold of mountains and deep trenches and often create powerful earthquakes. This is how the Himalayas and the border of Nepal and China, the Earth's highest mountain, Mount Everest, was formed. 2. Divergent boundary. Two plates are moving in opposite directions as in a mid-ocean ridge. These movements forms a gap between plates which allows magma to sieve through and cool to form new geological features such as volcanoes. The mid-ocean ridge under the Atlantic Ocean is an example of a divergent plate. 3. Transform boundary. Plates slide past each other, creating fault lines and frequent earthquakes. An example of this is the San Andreas Fault. Let's take a closer look at the major tectonic plates that shape the Earth's surface. First, we have the Pacific Plate, the largest tectonic plate, mostly oceanic. This plate stretches across the vast Pacific Ocean. Next is the North American Plate. This plate covers not only North America but also part of the Atlantic Ocean. Moving across to the Eurasian Plate, which spans Europe and Asia, connecting these two major land masses. The African Plate takes up the entire African continent and the surrounding oceanic crust. Then there is the South American Plate, which includes all of South America and part of the Atlantic Ocean. Down south, the Antarctic Plate dominates Antarctica and the surrounding oceanic areas. Finally, we have the Indo-Australian Plate, which covers Australia, India, and the surrounding oceanic regions. All of these plates are constantly moving, slowly but powerfully, reshaping the Earth's surface as we speak. Isn't it incredible? To wrap up our adventure, plate tectonics is like Earth's grand puzzle game, where shifting plates create mountains, spark earthquakes, and shape our world. It's a thrilling process that keeps our planet ever-changing. Thanks for coming along in this journey. Until our next exploration!